Right, so here's another problem involving the golfer Jordan Spieth. And so we saw in the last video that the distance that he drives the golf ball is modeled by a normal distribution. The mean is 304 yards, standard deviation is 8 yards. So on a different golf hole, he has the opportunity to drive the ball onto the green if he can hit the ball between 305 and 325 yards. Okay. What percent of his drives will travel a distance that falls in that interval, and is he likely to get the ball on the green with his drive? Okay. So I'm going to, again, highlight what's important. Okay. So the shape of the distribution, the mean, the standard deviation, and the interval. Okay. So he's trying to get his ball between 305 and 325 yards. So let's sketch it first. Okay, so 1, 2, 3, 4, 5, 6, 7 tick marks. Okay, so 304 was the mean, and we're going to go increments of 8. So 312, 320, 328, 296, 288, and 280. Okay, and this is distance in yards. Right, so the question is, what percent of his drives will travel between 305 and 325 yards? Okay, so 305 is just a little bit bigger than the mean. And 325 is close to his max distance. So let's shade this. So our general strategy has been to take a data value and convert it to a z-score. But in this case, we have two data values, right? 305 and 325 yards, okay? So we're gonna have to convert both of those into z-scores. All right, so let me just write the formula. Data value minus the mean over the standard deviation, okay? So we'll do 305 minus 304 divided by 8. And then we'll also do 325 minus 304 divided by 8. Okay, so we're going to convert both of those distances in yards into z-scores. Okay. All right, so 305 minus 304 is only a difference of 1 yard. But since the standard deviation is 8, the z-score would be 0.125. Okay. Now I'm going to go ahead and round that to 2 decimal places because I know when I go to use table A, it only allows me to look up 2 decimal places. Okay. All right. The other z-score, 325 minus 304, is a raw distance of 21 yards. Divide that by an 8-yard standard deviation, and you're looking at a z-score of 2.625, which again, I'll just round to 2 decimal places, 2.63. All right, so now we've got 2 z-scores. So we're going to have to now look each of these z-scores up in the table. Okay. And so I'll just kind of sketch what I'm doing here. Okay, so we're going to look up the z-score of 0.13, and then we'll also look up the z-score 2.63. So 0.13 gives us a percentile of 5517. And then a z-score of 2.63, gives us a percentile of 9957. Okay. Now, neither one of these is the correct percentage, right? You can tell from the shading, right, that this is definitely less than 50%, right? What's shaded here in green is not even the full right half of the normal curve, right? So I can tell before I did any calculations that the answer is going to be a little bit less than 50%. Okay, so this is 55% and this is 99%. Okay, neither one of those is correct. Okay. So what are these numbers representing? Okay. Well, the 99% is telling us that 99% of the drives will be less than 325 yards. Okay, so it's what we want plus this extra region here, which is not shaded. So the sum of these two regions is 9957. Okay, the 5517, the 55% is telling us the percent of drives less than 305, right? So this percentage is the area of this unshaded tail. Okay, so if we want just the area of the green shaded tail, we're going to take the larger percentage and subtract the smaller percentage, and that'll give us the difference. The difference is what we want here. Okay. So if we take 9957 minus 5517, we should end up with a value that's a little bit less than 50%. Okay, so it's 0.444. Okay, so about 44%. Okay, and that matches our sketch, right? And this is the reason why it's important to make a sketch, right? So that you have kind of a natural feeling for what the right answer should look like. All right, so then let's write a sentence. So let's say about 44% of his drives will travel 305 to 325 yards. Okay, so is he likely to get his ball on the green? Well, it's a less than 50% chance. So I guess you could technically say he's not likely, although it's not horrible chances, but it's less than half. Okay. All right, so let's say we didn't want to do everything through the table, right? Let's say we wanted to use, right, that command on the calculator, okay? And then here's where there's a little bit of an advantage, okay? So we got the z-scores of 0.13, that was a z-score for the left side, and 2.63, that was a z-score for the right side. Okay, if we put those z-scores in for the lower and upper bound, 0.13, 2.63, okay, and then we're going to leave the mean and standard deviation as 0 and 1, right, because we're dealing with z-scores now. We're not dealing in the units of yards anymore. Okay, we should get an answer there, right, 44%. Okay, so it's a lot quicker and easier to do on the calculator, right, which makes sense, right? Technology should be quicker than looking things up in a table. Okay, so there's the final solution. And then I've got one more video coming up where we're going to do these calculations in reverse.